Good morning, students. So the chapter that we are being studying today is haloalkanes and haloarenes. So this is a part of the organic chemistry chapter, and yes, so we'll see what exactly haloalkanes and haloarenes are. So what is organic compounds basically? So organic compounds are compounds that are made up of carbons. So all organic compounds are the ones which are made up of carbon. Yes, so organic compounds play a very important role because organic chemistry is a different kind of a branch. Okay, it deals with something very different which is not a part of physical chemistry. It deals in all reactions, it deals in all mechanisms of reactions. So the starting part for this, so the base of organic chemistry we could say was alkanes, alkenes and alkynes, and now what the next part, the next level you could say is haloalkanes. So what exactly haloalkanes is? So alkanes, like we studied, are sp3 bond hybridized single bond reactions, and halo is your halogens. So halo is your halogens and alkanes are your sp3 hybridized single bond atoms. Okay, so now we'll just move into the basics a little. What if the number of carbon is 1, the name given is meth. If the number of carbon is 2, the name given is eth. This is the basics of organic chemistry. If the number of carbons is 3, the name given is prop. If the number of carbons is 4, the name given is bute. If the number of carbons is 5, the name given is pent. If the number of carbons is 6, the name is hex, and if 7, the name is hept, and so on. There is 8, there is 9, and there is 10. Coming back over here, like I said, alkanes are single bond and they are given the name ane as the suffix at the end. Alkene, that is double bonded double bonds, and that is ene given as suffix. Alkyne is triple bonded atoms and the name given is yne at the suffix. So this is all the basics that we have done maybe in the 11th standard. Now moving on, what are alkanes? So we'll focus a little bit on what alkanes are. Okay, so alkanes have the formula CnH2n plus 2. So what exactly happens over here is CnH2n plus 2, which means there is n carbon and hydrogen is 2n plus 2. Okay, so alkanes are basically made up of carbons as well as hydrogens. They do not contain any other element. If they contain any other element, that element becomes a functional group. Okay, now what is CnH2n plus 2? So suppose if I put Cn as 1, so this becomes carbon 1, hydrogen 2 ones are 2 plus 2, so that is hydrogen 4. So that is C1H4, and that gives us the name methane. How the name methane is because one carbon, and as we saw, one carbon is meth, and as we know that this is only single bond, there is only a single bond between them, therefore the name ane. So this is methane, that is meth stands for one carbon and ane stands for alkane. Okay, now what is more important over here is that this is called as an alkane group. Now I want you all to understand what is an alkyl group. So an alkyl group is with the same formula except there will be a minus 1. So that becomes CnH2n plus 1. Here. And alkyl groups are represented by the letter R. So suppose if I want alkyl, that is methyl, then I will have the formula C1H3. So CH3 is methyl. In the same way, C2H5 is ethyl, C3H7 is propyl, and C4H9 is butyl. So now I hope this is very clear what alkyl groups are. So alkyl groups are CH3, C2H5, C3H7, C4H9, and so on. Moving on further, now we are done with the basics to revise what we need in this chapter. Now moving further, what are haloalkanes? So haloalkanes are derived when you substitute the hydrogen from an alkane is substituted by X, where X is your halogen. Okay, so once again we'll go through what haloalkanes are. Haloalkanes are derived when an hydrogen is substituted from an alkane. From an alkane, when you remove a hydrogen and you substitute it with a halogen group, we get haloalkanes. The general basic formula is Rx, where R is your alkyl group and X is your halogen. So now, as we know what alkyl groups are, our alkyl groups are methyl, ethyl, propyl, butyl. Now let's look at what other halogens we have. So halogens is basically our group 17 in the periodic table, to the very right hand side, just next to the noble atoms, and these are our halogens. Okay, to sum it up in short form, first class biryani I ate. First class biryani I ate. F stands for fluorine, Cl stands for chlorine, Br stands for bromine, I stands for iodine, and At stands for astatine. So in this way we can summarize our halogens. So we have 5 halogens, out of which 4 are usually used and astatine is not used. So just as like we know now what haloalkanes is, it is the formula Rx. So now you can put an R over here, you can put an X over here, and you can get a varied range of haloalkanes. So now if I put R as CH3 and X as Cl, here I get CH3Cl, which is methyl chloride. If I put C2H5Cl, where C2H5 is ethyl and this is chlorine, so I will get ethyl chloride. Similarly, CH3Br will be methyl bromide, and so on. So once when we learn the nomenclature, how to name our compounds, we can go further deep into that. Okay, so this is all about what haloalkanes are. Now moving further into haloalkanes, let's see how our haloalkanes are classified. So classification is basically is done into three different types. The first type is basis on the number of halogens. So first classification will see how many number of halogens I have in my molecule. The second one will see the compounds containing sp3-CX bond. What is an sp3 bond? An sp3 bond is a single bond, which means that the halogen is attached to the carbon atom which has a single bond. And compounds containing sp2-CX bond, which means that the halogen is attached to the carbon which is a double bonded carbon. As because sp2 are double bonds, so halogen which is attached to carbon which is attached to a double bond. So yes, so these are the 3 different groups in which we are going to see how our haloalkanes are classified. The first one, on the basis of halogens. So on the basis of halogen, the carbon compounds, the haloalkanes, are grouped into C2H5X, that is your monohalogen, your dihalogen, and your trihalogen. So what is monohalogen? Monohalogen is when we have one halogen group present in the whole molecule. That is when one hydrogen group is replaced by a halogen group, we get a monohalogen. So here the simple example is C2H5X. The next one is dihalogen. When 2 hydrogen atoms are replaced by 2 halogen atoms, we get a new molecule which has 2 halogen atoms, and that is called as a dihalogen. What is trihalogen? When 3 hydrogen atoms from an alkane are replaced by 3 halogen atoms, we get a new molecule which has 3 halogens, and that is your trihalogen. So this is how you classify your haloalkanes based on the number of halogen atoms present in them. So we can have max to max only 3 to 4 halogen atoms in a molecule, because we know that carbon makes only 4 bonds. Next, compounds containing sp3-CX bond. Like I told you all, here sp3-CX bond stands for the halogen which is attached to the carbon atom which is attached to a single bonded carbon atom. Okay, sp3 defines the structure of this carbon. So it says that this carbon is a single bonded carbon atom. Now, so alkyl halides. Okay, so the first one is primary. So the first one that we're going to see is the different types of the alkyl halides. So first one is primary, second is secondary, and third is tertiary. So what do these actually mean? In primary, the halogen atom is attached to the carbon atom, which is attached to just one more carbon atom. Once again, halogen atom is attached to the carbon atom, which is attached to just one more carbon atom. Then we get primary. Primary is also denoted by 1 degree. So 1 degree is called as primary. So how do I see if my halogen is primary? So when a halogen is attached to a carbon atom, which is attached to just one more other carbon atom, that compound is primary. So for example, we have an alkyl group over here. We have a carbon which is attached to HN. Now here the halogen is attached to a carbon atom, and the carbon atom is attached to just one other carbon or one other chain of carbon atoms. That's why it's called. Its two other bonds are just to oxygen. If it's to one other bond would be to carbon, then two bonds would be to carbon, and that would be secondary. Here only one bond goes towards carbon, and that's why it's primary. In secondary, the halogen atom is attached to the carbon atom, which is attached to two more carbon atoms. So let's see the example. Halogen atom is attached to carbon atom, which is attached to two other carbon atoms, and that's why this will be called as secondary. In tertiary, our halogen atom will be attached to a carbon atom, which will be attached to three other carbon atoms. So halogen atom attached to carbon atom attached to three other different carbon atoms. So in this way we get primary, we get secondary, we get tertiary. So this is the first type of classification in our compounds containing sp3CX bond, and that is alkyl halides. Now moving, we have allylic halides. In allylic halides, the halogen is attached to a carbon which is attached to a doubly bonded carbon atom, which means my halogen is attached to a carbon which is attached to a doubly bonded carbon atom. This carbon atom over here is attached to a double bond. So this was just one small example. The halogen is attached to a carbon which is attached to a carbon which is a double bonded, which is a doubly bonded carbon atom. So this is all about allylic halides. Moving on, we have benzylic halides. In benzylic halides, I have my halogen which is attached to a carbon which is attached to a benzene ring. Halogen is attached to a carbon which is attached to a benzene. Once again, what is benzylic halides? Halogen is attached to a carbon which is attached to a benzene. Halogen is attached to a carbon which is attached to a benzene. So here we get a benzylic halide. Once again, summarizing allylic and benzylic halides. In allylic, we have an halogen which is attached to a carbon which is attached to a doubly bonded carbon atom. And in benzylic, we have a halogen which is attached to a carbon which is attached to a benzene ring. So I hope allylic and benzylic. So in compounds containing sp3CX bond, we have alkyl halides, we have allylic halides, and we have benzylic halides. So there are three types. Now moving forward. Compounds containing sp2CX bonds. The third classification of haloalkanes is compounds containing sp2CX. So as said before, sp2 is the structure of the carbon atom which is attached over here. So in that we have vinylic halides and we have aryl halides. So what are vinylic halides? The halogen is directly attached to a doubly bonded carbon atom. Halogen is attached to a carbon atom which is doubly bonded. So just vinylic halides are similar to allylic halides, only the thing there is no intermediate carbon atom like the allylic halides. In aryl halides, again it's same like the benzylic halides, only there is no intermediate carbon atom. So the halogen is directly attached to a benzene ring. Again, summarizing vinylic and aryl halides, we have in vinylic the halogen is directly attached to the doubly bonded carbon atom, and in aryl halides the halogen is directly attached to the benzene ring. The examples: halogen directly attached to a doubly bonded carbon atom and halogen directly attached to a benzene ring. So this was about the classification of haloalkanes. Now we move on to the next part, that is the nomenclature. Nomenclature becomes very important when we want to name our alkanes and when we want to give them a proper name and we want to classify them and we want to properly use them in reactions. That I'm calling them with proper names becomes very important. So nomenclature is a very important part in organic chemistry. Each chapter from now on will have his own nomenclature. Like if you're studying alcohols, you will have its own nomenclature for alcohols. But the basic steps that we learned today are going to be used in all other nomenclatures. So just do pay attention at this part. So as we know that haloalkanes is Rx, that is R stands for our alkyl group and X stands for our halogen. So now when I have an haloalkane, how do I name it? Okay, so that is what we're going to be studying today. So as we know that we have two different nomenclatures, one can be the common name and one more will be the IUPAC name. So in the common name is much simpler. It's just a common name that we give to the compounds, like it can be propyl bromide, or it can be isopropyl chloride, something like that. So all these are common names. But IUPAC names are well-defined set of names by the IUPAC committee. So these names have a step to follow, and once you follow that steps, you can write the name on your own. So what are these steps? First step, and we are going to use these steps throughout the nomenclatures that we see. So please do pay attention at the steps. So IUPAC names. The first step would be the longest chain of carbon atoms. I need to find from the reaction given to me the longest chain of carbon atoms. And then I'll start numbering from where the substitutes get close number. So once I have my longest chain, I will start numbering. I need to number my chain from 1, 2, 3 and so on till the number of carbon atoms are there. I will be numbering only the main chain and my substitutes. So where my substitutes get the closer number, from there I'll be starting my numbering. I'll name the substitutes. So now I'll start naming my substitutes by using the number that they have got. Number of carbons will decide the main name. So suppose if I have 5 carbons in my long chain, then in my longest chain, if I have 5 carbons, then the name of my compound will be pentane. If I have 4 carbons in my longest chain, then the name of my compound will be butane, and so on. And then finally we'll write the IUPAC name. So now let's see how we use these steps in practical purposes. The first example before us is CH3, CH3, CH2, CH2, Br. Okay, so let's move on and see what exactly this is. So first I'll be finding out my common name. So in common name we can see that it is a straight chain of carbon atoms with a bromine. So the name given to it is N-propyl bromide. The name given to this is N-propyl bromide, which means that there is a long chain, that is a N stands for the long chain of carbon atoms, and bromide stands for bromine, which is our halogen over here. So N-propyl bromide. It follows the basic format of alkyl halide. Common names follow the basic format of alkyl halide, while as IUPAC names follow haloalkanes. Okay, yeah. So suppose if I have bromomethane, or if I have bromoethane, or if I have pentyl chloride. So the basic formats are haloalkane and alkyl halide. Now moving on to our IUPAC name. So we'll apply the steps to other. First I will find the longest chain of carbon atoms. So as I can see, the longest chain is over here with 3 carbons. Then what I can see is that I have a substitute over here. So I will number my chain. So I have 2 ways of numbering my chain. One could be 1, 2 and 3, and the other could be 1, 2 and 3. But I will choose the one where my bromine is getting the smallest number, because it is a substitute. If I choose this carbon, the bromine will get number 3. But if I choose this numbering 1, 2, 3, the bromine will get number 1. And so I select this as my numbering format, that will be 1, 2 and 3. And therefore the name of this compound will become haloalkane. So 1 bromo, 1 bromo pentane, 1 bromo propane, because there are 3 carbon atoms. So the name simply becomes 1 bromo propane. Now moving on to our next. If you could see the second example over here, it is CH3, CH, CH3, Cl. In this example, as you can see, Okay, so now what will be the common name for this one? The common name for this one will simply be isopropyl chloride. The reason being isopropyl is always given whenever we have CH3, CH and CH3. So now this Cl and CH3 groups can be interchanged, and therefore I can write Cl here and CH3. So whenever you see something like this CH3, CH, CH3, always you can use isopropyl chloride. This can also be written as sec-propyl chloride because this halogen is attached to a carbon atom which is attached to two other carbon atoms, and therefore the name can also come sec-propyl chloride. So this is what the common name is, that is isopropyl chloride. Now moving on to the next one, we'll write the IUPAC name. For the IUPAC name, let's find the longest chain. So this would be our longest chain. Let's start the numbering. I think numbering from this side would be 1, 2, 3. If I try numbering from the other side, it will be 1, 2, 3. So what I can see that the number doesn't matter over here. Both the side it's 1, 2, 3, 1, 2, 3, and therefore my name for my compound would be, the substitute over here will first be given 2-chloropropane, and therefore the name 2-chloropropane. So I hope this example is very clear. Moving on to the next one. Yes. So now in this example we have CH3, CH3, CH, CH3, Cl. Now in this example, let's see what can be our common name. Now like I told you all, see if there's CH3, CH, CH3, it's straight away iso. So I can write over here isobutyl chloride. So my common name for this one is isobutyl chloride. Whereas my IUPAC name would be first to find out the longest chain. So once I find out my longest chain, what I'll be getting is, now if I start numbering it, if I try numbering it, if I start from here, I'll start 1, 2, 3. Then my CH3 will be getting the number 2 and my Cl will be getting the number 3. But if I start numbering from this side, 1, 2, 3, my Cl will be getting number 1 and CH3 will be getting number 2. So here, so this side is the 1. When I start 1, 2, 3, this my substitutes are getting lower number, and therefore I'll be selecting 1, 2, 3 as my format of numbering, and therefore the name for this compound will be. Now another problem over here is that I have two substitutes, that is chlorine and CH3. Both have numbers, one is 1 and one more is 2, but I will be writing them in the form in which their alphabetical order comes first. So if we see that chlorine starts from C and methyl starts from M, therefore I'll be writing chlorine first and then methyl. So it will be 1-chloro, 2-methyl propane. So I hope this example is also very clear. Moving on to the next example, we have CH3. Yeah, so we have now what about this compound? Okay, so yes, so now when I'm writing the common name, like you saw, if there is CH3, CH, CH3, we call it iso. But now when there is CH3, 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 CH, we call this neo. So this is neopentyl chloride. The common name straight away for this is neopentyl chloride. While looking at the IUPAC name, we will first find the longest chain. So when I'm finding my longest chain, I will have 3 chains of carbon atom as my longest chain. Now numbering the chain. So like I can see here, I have 3 substitutes, 1, 2 and 3. So when I have 3 substitutes, so naming them would be 1, 2, 3, because if I start from here, my chlorine will get number 3. So when I'm starting from here, my chlorine is getting number 1 and they are getting number 2. Now once again, as we know that we have to follow the alphabetical order, therefore chlorine will come first and methyl will come next. But now there are 2 methyls, so I will be writing 2,2 dimethyl propane. So I hope this example is very clear. So the name of this compound will be 1-chloro 2,2 dimethyl. Di stands for 2 propane. If I have 3 methyls, then it will be trimethyl, and if I have 4, it will be tetra, and so on. So moving with the IUPAC name, 1-chloro 2,2 dimethyl. So I hope this also example is very clear. Moving on to the next one. Now in the next example, first let's see the compound given to us. It is CH3C CH3 CH3B. And this example, like we can see that we have a bromine which is attached to Yeah, like I said, CH3C, CH3C, we can call it neo, but here we have bromine directly attached to carbon, and therefore we'll call it tertiary butyl bromide, because the bromine is directly attached to a carbon atom which is attached to 3 different carbon atoms. Now naming the IUPAC name would be very easy because we know the steps right now. So my longest chain of carbon atom, that would be 3 only, and my substitutes will be Br and CH3. So if my Br is attached to my so like I can see I have 2 substitutes, and therefore numbering 1 2 3 or 1 2 3 would be the same thing. So I will take 1 2 and 3, and therefore the name for this one would be 2-bromo 2-methyl propane. So here now if I have 1 carbon and 4 chlorines. So now there is no longest chain, there is only 1 carbon, so I know that the name is that the name will be methane, but I have 4 chlorines, so it will be tetrachloromethane. Tetra stands for 4 chlorines, 4 chloromethane, so tetrachloromethane. In the last example that I have for you all, it is CH3CH double bond, CH3Br. Now in this, let's try and find the longest chain. So when I find the longest chain, I will find that I can make a longest chain of 5 carbons. So my substitute over here is only Br, but I can see that there's a double bond, so this one also acts like my substitute. So when I start numbering it, if I start 1 2 3 4 5, my double bond gets the lowest number, that is, it gets 4, while the priority of double bond is always more than bromine, and therefore I'll start numbering from 1 2 3 4 and 5, and therefore I can see that it's a 5 carbon compound, and therefore the name will be pent. Now how do I write this? So as we have studied in alkenes, that we write ENE, replacing the E of the alkane or the E of the pentane with the ENE, and therefore the name for this one will be 4-bromo pent 2-ene. 2 says that the double bond is at the second carbon, so the name will be 4-bromo pent 2-ene. So I hope the nomenclature is very clear. Now we'll move on to some exercise which I'll be giving you all, and hope you all will be able to solve it. So some very easy exercises and very small. So the name, so the compound over here that we have with us is C2H5, CH3CH, CH2CH, CH3Br. So like you can see, this is the compound. But now what is happening is, if you see, people will say that CH3CH, CH2CH, CH3, this is the longest chain, that is 1 2 3 4 5. But they actually miss out on the C2H5 over here, which is hidden. So if I expand this, it will look something like this. And then you can see that the longest chain will be 1 2 3 4 5 6, that is of 6 carbons. So this is where you can get caught, and this is very important to understand. But when I write the name of this will be very simple. This will be my substitute, this will be my longest chain. So I'll be having 2 substitutes, one here, so I can start numbering 1 2 3 4 5 6, and therefore my name would be 2-bromo and 4-methyl hexane. So I hope that's very simple. If I'm writing the structure of this one, 1,4 dimomobutene, so how do I start? So while starting for this, first I need to see what is there over here, that is butane. So I will write 4 carbons straight away. 1 2 3 4. Once I write 4 carbons, then I will look at what is given. So at second one, it said that I need to put a double bond, so I will put a double bond at the second. Then what is said to me is that 1,4 is dibromo. So 1,4. So 1 there is a bromine, and on 4 there is a bromine. So 1 2 3 4. So on 4 also I will add a bromine. And what I will do is, remaining all I will fill with my hydrogen atoms. So here I can see that so here I can see that there is CH2 needed. Here I can see that there is only CH needed. Here also only CH, and here there is CH2. So this is my compound, 1,4 di. So it's very simple. Always you write, if whatever butene is there, you take 4 carbons, you place them, and then wherever there is double bond, you add a double bond. Wherever bromine is there, you add a bromine, and rest fill it with hydrogen atoms. So this is how you write a structure. And the last one is classify as primary, secondary, and tertiary. So now here, as we can see the first example with us, CH3, CH2, 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 CH2Br. As we know that primary is when the halogen is attached to a carbon atom which is attached to only one other carbon atom. So like we see here, bromine is a halogen which is attached to a carbon atom which is attached to only one other carbon atom, that is one other chain of, therefore this is 1 degree, that is primary. Here the halogen is attached to a carbon atom which is attached to two other carbon atoms, therefore this is secondary. Here the halogen is attached to a carbon atom which is attached to three different carbon atoms, and therefore this is. And this is the end. With this we can end our haloalkanes first part, and now in the next part we'll be moving on to the preparations and reactions, where I'll be telling all how to easily remember the preparations and reactions of haloalkanes. So stay tuned. Thank you.
Thank you for watching. Visit us at needbook.in.